Okay, so now today I would like to talk about the homework for the following for these problems. It's like I have to do for the limits, cos, Laplace transform, inverse Laplace transform, and integrate function, integrate differentiate and integrate function for the following programs with the using of the MATLAB. Okay, this one is a limit. So we need to know that because we are using the we are using the limit function because and then this is already written in the program and we have to use the function. So we have to know the input arguments and their description, something like that. For this is for the limits. For the limits, we have to know for the f is the input for the limits. Var is a variable. A is a upper limit. Upper limit point, something like that. So okay, so now here in the maplet, there is five types of limits that we can use. There's the first one is the bidirectional limit, and another one is the four variable, and another one is a limit limit f. If we use limit f, it will reach to 0, and if we use limit with the left and right and something like that, so it is a right side limit and left side limit and the right side limit. Okay, for the another function, I'm going to explain about the Laplace transform. Laplace transform is pretty simple. It's a changing from the time domain into the Laplace domain. So by using the Laplace function, we can change from the time domain to the Laplace domain. For also in the Laplace transform, we have three inputs. F is the input, var is a variable, and transvar is the transformation variable. Yes. So now for the syntax, we can use like this Laplace if with the input, and another one is the Laplace with the transformation variable. Another one is the Laplace with the Laplace function with the input variable, independent variable, and the transformation variable, something like that. Then another one is the inverse Laplace. If we can do the Laplace, and we have to, if in sometimes we have to change from the time domain to the Laplace domains, and we also have to transform from the Laplace domain to time domain. If we are going to use for the microcontrollers from the Laplace domain, okay, we have to change it into the time domain first. After that, we can put our equations into our microcontrollers. This one is for the inverse Laplace domain. It is also same with the Laplace function. It is also have an input variable and transvariable. Then this one is for the differentiate, integrate. Differentiate is really important because everything we have to do is deals with the differentiate, and also if for the dynamics model in dynamics equations, a kinematic equation, we have to deal with the differentiation. Okay, for the differentiation, there is a five input arguments. One is the exponential of function to differentiate. It's a function to differentiate. Another one is a differentiation parameter and differentiation order. This function this expression or function differentiation parameter and differentiation order, these three are important, and then the another one is a variable, something like that. Okay, for the syntax, we only have three things. One is a is a x, and another one is a differentiator x with the differentiation order, differentiation x, and the dimension. And another one is that this one is for the integration. Integration is an integration. Integration needs the expression integrand, integration variable, and lower bound and the upper limit. This is called the lower limit or the upper limit, something like that. So for if we use the integral, we have to do for the upper limit or lower limit, or just integrate the function, something like that. Okay, so this is how this is the index arguments for the syntax and arguments for the using these kinds of equations. And then now I'm going to show the about the output of the of this integration. Okay, this one is for the 2.1 limits, and if we enter this one, the answer is 0. And comment again, and I will show the another one for the Laplace. Okay, if I'm going to do this equation into the Laplace transform, the answer is like this. And if I'm going to do the inverse Laplace transform, and come on, comment. Okay, in plus Laplace transform, the answer is like this. But we have to know that if we're going to write the system with the unknown variables, we have to announce them as a SYMS systems as a SYMS with the variable name, because it is important. If we are not trying to announce if we are not trying to announce the variable with like this, the we can't get the output from this one. Okay, okay, and another one is for the differentiation and comment, and I will play this one. Okay, this is the answer for the differentiate of this this equation. And then another after that, I will do a comment again, and now it's for the integrate equation. If I do the integrate equation, there will be two answers, because there is a because also from the questions, there's a two integrate equations, and then this is my final output of the integrals. Okay, thank you so much for your time and your attention. Thank you so much, sir.